So today we're going to be introduced to the concept of a matrix. A matrix is a rectangular array of numbers written within brackets. A matrix is represented by a capital letter and is classified by its dimensions or size. The dimensions of a matrix is always given by the number of horizontal rows by the number of vertical columns. So let's look at an example. Example A here. This is called matrix A. Notice it's named with a capital A. So when we talk about matrices, we want to use capital letters. This is a 2 by 3 matrix because it has 2 rows. Rows are left and right. Rows are horizontal. And it has 3 columns. Columns are vertical. So this is a 2 by 3. It's important that you can state the dimension of a matrix. You're going to need to be able to do that. So, example 1 says write the dimensions of each matrix. So pause the video and see if you can do these before I work them out. Alright, so if we look at A here, this has 3 rows and 4 columns. So A is a 3 by 4 matrix. We write it out just like that. B, how many rows does it have? 1. How many columns does it have? 3. So it's a 1 by 3. And then C has how many rows? It has 1, 2, 3, 4, 5 rows. How many columns? Just 1. So this is a 5 by 1 matrix. Okay, each number in a matrix is called a matrix element. You can identify a matrix element by its position within the matrix. When you're talking about elements, we're going to use lowercase letters with subscripts for naming the elements. The subscript represents the row and the column that element is in. So let's look at an example here. So notice, this is my matrix A. I'm using a capital A. All of these things inside here are called the elements. So when we're talking about those, since this is called matrix A, we're going to use a lowercase a. Now this is not A sub 13. This is actually A sub 1, 3. If you want to, you can put a comma in between those two numbers. The 1 tells you the element is in the first row. So the 1 is in the first row. That's what 1 means. The 3 means it's in the third column. So if we go to the first row, which is this row, and we go to the third column, the element that's in that position is 9. So A sub 1, 3 is equal to 9. So again, pause the video and see if you can work these out. It says identify each element. So A sub 3, 3. So we are looking for the element that's in the third row and the third column. So that would be 99. So A sub 3, 3 is 99. A sub 2, 1. Well, the 2 means the second row. The 1 means the first column. So that would equal 0. And then the last one, A sub 1, 1, that would be the first row, first column. So the element would be 1.2. All right, the last thing I want to look at today is adding and subtracting matrices. So I'm going to give you the rule for adding matrices. To add matrices, they have to have the same dimensions. If a matrix, if you're adding two matrices and they don't have the same dimensions, you can't add them together. The sum doesn't exist. So you got to make sure they have the same dimensions. And then it's really easy to add them together. It works the way you probably think it's going to work. What you do is you add corresponding elements, which are the elements in the same position. So let's look at this example. It says find each sum. Well, this matrix is a 2 by 3. This matrix is a 2 by 3. So I'm adding two matrices that have the same dimensions together. So I can do that. So here's how it works. It's really simple. The answer is going to be another matrix that's a 2 by 3. You take the element that's in 1, 1 in both matrices and add them together. So 1 plus 3 is 4. And then you take the element that's in position 1, 2 and add it to the element in position 1, 2 over here. Negative 9 plus 2 is 7. And then last, we would take 0 plus negative 3, which is negative 3. So there's our first row. And then we just do it all over again. Now I would take, oops. So now, I would take the element in position 2, 1 and add it to the element in position 2, 1. 3 plus negative 9, negative 6. Negative 5 plus 6, 1. And then last, 7 plus 12, 19. So this is our answer. All right, let's look at B. Well, the first matrix is a 2 by 2. The second matrix is a 2 by 1. They don't have the same dimensions. That means we can't add them together. So you just say the sum doesn't exist. Or it's not possible. Yeah. All right, one last thing before I end this video. You can multiply a matrix by a number. That number is called a scalar. When you do this, you just multiply each individual element by that number, by that scalar. Okay? This is called scalar multiplication. So I'm going to do this last example. You see this little 2 outside my matrix? That's a scalar. So when you see a number in front of your matrix, it's like the de Sitter property. Basically, what you're going to do is you're going to take that 2, you're going to multiply by all the elements in this matrix only. Because the 2 is just only in front of that matrix. So when we do that, we get negative 2, 0, 18, negative 6. And then I'm subtracting that from this matrix. Okay? I haven't gave you the rule for subtracting. Oh, so far I gave the rule for adding. So here's what you do to subtract a matrix. What you do is you change it to addition. So you change this minus sign to a plus sign. And then what you're going to have to do is you're going to have to multiply all of these by negative 1. You have to use the scalar multiple, times this all by negative 1. Basically, when you are subtracting, okay, we want to add because adding is easier than subtracting. You'll make less mistakes. So here's what I'm going to do. So I'm going to change the minus sign to a plus sign, and then I'm going to change each element inside here that follows the minus sign to its opposite. And now, I just add these two matrices together. They're both 2 by 2s, so we can add these together. So -2 plus -3 is -5. 0 plus -4 is -4. 18 plus -5, 13. -6 plus -5 is -11. So this is my answer to that expression.